It's called completing the square. And what you need to go back and do is first remember what perfect square trinomials look like. So I get a perfect square trinomial by squaring a binomial. Remember, x plus 3 quantity squared is not just x squared plus 3 squared. It really means to take x plus 3 and multiply it by itself. When I do that, if you remember, I'm going to take the x and distribute it to the x plus 3. That would give me x squared plus 3x. And then the 3 and distribute it to the x plus 3. So I get a plus 3x twice for the plus 6x, and then the constants multiplied together would give me the plus 9. Same thing over here. I'd have 4x squared minus 10x minus another 10x, and then plus 25. So if you see, actually the form of a perfect square trinomial is a squared plus 2 times a times b plus b squared, if my original binomial that I'm squaring is just a plus b quantity squared. So this is really my 2x multiplied by itself, my negative 5 multiplied by itself, and this is 2 times my 2x times my negative 5. So when I'm completing the square, I'm trying to create a perfect square trinomial. So the first thing I'm going to do is just go ahead and get the constant on the other side of the equation. So x squared plus 2x, and I'm going to leave myself some room, equals positive 3, because I've added 3 to both sides. Now I'm going to create a perfect square trinomial on the left. If you remember, that middle term is 2 times the first term, which is not the x squared, but times the x, times the last term. So what I'm going to do is I'm going to take the coefficient of the x, divide it by 2, and then square it to get the number that needs to go here. Well, 2 divided by 2 is 1, squared is 1, so I would have to add 1 to this side to make this a perfect square trinomial, and to maintain balance in my equation, I'm going to add 1 to the other side. This is actually x plus 1 squared. And this side then is 4. Now I'm going to skip a little bit of the work here. I'm going to square root both sides, but remember I need to look at both the positive and negative roots on the right side. So when I square root this, it's just x plus 1. When I square root this, I'm going to get both positive and negative 2. So I'm going to have one equation, x plus 1 equals negative 2, and my other equation, x plus 1 equals positive 2. And then I'm just going to solve those. Subtracting 1 from both sides, one of my zeros or solutions is x equals negative 3. The other one is x equals positive 1. So if I graph the equation y equals x squared plus 2x minus 3, it's going to cross the x-axis at negative 3 and positive 1. Now, yes, this one was factorable, but if it says solve by completing the square, make sure that that's the method that you use. So same thing, and we're going to get into something here where first we have to have this as a 1x squared. But as long as this is a 1x squared, I'm going to add 22 to both sides of the equation to get the constant on the other side, leaving myself some space. To find the number that goes here, I'm going to take 16 and divide it by 2, and then square it. So 8 squared is 64, so plus 64. To maintain the balance, I'm going to add 64 to the other side. This is really x plus 8 squared, and I get 86 on the other side of the equation. Now, when I square root, 86 is not a perfect square, so I square root this side and I get x plus 8. I'm just going to leave this as the negative square root of 86 for one of my equations, and x plus 8 equals the positive square root of 86 for the other equation. This is going to be one of the cases where I have to round my answer to 3 decimal places because I'm going to have an irrational number here. So x is going to equal negative 8 minus the square root of 86, and x is going to equal, when I subtract 8 from both sides, negative 8 plus the square root of 86. I'm going to plug this into my calculator. Notice I did not put this in my calculator and round it first. I'm going to plug this whole thing in my calculator at once. And this x to 3 decimal places is negative 17.274. And this x to 3 decimal places is x is 1.274. So I had to round that one. I couldn't just do it as a fraction, and I don't want you to leave those radicals in your final answer. Now, in order to create that perfect square trinomial, one thing you have to do is the coefficient of the x squared needs to be positive 1. So the first thing I'm going to do is just divide everything by 7. So I end up with x squared minus 2x minus 8 equals 0. Then I'm going to go through the rest of my process. X squared minus 2x, leave myself some room, equals positive 8. I'm going to take this negative 2 and divide it by 2, and then square it to get what goes here. So that's going to give me positive 1. I'm going to add 1 to both sides. Now be careful, with this being this, this is the number I'm looking at. So x minus 1 squared would give me x squared minus 2x plus 1 equals 9. Square root both sides and set up my two equations. So x minus 1 would equal negative 3, and x minus 1 would equal positive 3. So solve. X equals negative 2 is one of my zeros or roots or solutions, and x equals positive 4 is the other. And again, what that means is if I graph the equation y equals 7x squared minus 14x minus 56, it's a parabola that crosses the x-axis in these two places. Now this one is more complex. First thing I might do is just get the constants combined on the other side of the equation. So subtracting 36 leaves a negative 32 over there. But then I still have to divide everything by 3 so that this is a positive 1x squared. And now I'm going to have to deal with this fraction in the middle. So I have x squared plus 20 x equals negative 32 thirds. So now I want to take my 20 and divide it by 2, which would be 26, which is 10 thirds, and then square it. And 10 thirds squared is going to be 10 squared is 100, 3 squared is 9. So I'm going to add 100/9 to both sides of the equation. This is x plus 10 thirds squared. And then negative 32 thirds plus 100/9 actually ends up being 4/9 when it's reduced. Luckily, this is a perfect square because these are both perfect squares. The square root of 4/9 is 2 thirds. So I have my x plus 10 thirds equals negative 2 thirds, and my x plus 10 thirds equals positive 2 thirds. When I subtract 10 thirds from both sides, negative 2 thirds minus 10 thirds is negative 12 thirds, which is negative 4. Negative 10 thirds plus 2 thirds is negative 8 thirds. I can't give that as an integer. There's no reason that I have to round it to 3 decimal places. I'm only going to round to 3 decimal places when I have to. So I'm just going to leave that answer as negative 8 thirds, or I could do it as a mixed number of negative 2 and 2 thirds. Either one of those is acceptable.